Okay, now the final problem of homework 7, problem 10. Shopper is 3 meters away from a convex security mirror, sees his image with a magnification of 0.25. A, where is the image? Okay, so if you're looking for the location of the image, you're going to start with minus the distance to the image divided by the distance to the object is the magnification. All right, and so we've got the magnification, we've got the distance to the object, right? So the distance to the image is just minus the distance to the object times the magnification is minus 0.25 times 3 is negative 0.75 meters. Okay, where is the image? The image is 0.75 meters behind the mirror, right? It's a virtual image. It is behind the mirror. Part B, what is the focal length of the mirror? Okay, so for part B, we go 1 over distance to the object plus 1 over distance to the image is 1 over the focal length, right? Okay, so we've got distance to the object, 3 meters, distance to the image, minus 0.7 meters. Let's start sticking these in. 3 meters minus 0.75 meters. Let's invert these. 1 over that. Whoop, equals 1 over that. I hit the hotkey that I didn't mean to hit. Okay. All right. And sum these. And now the focal length is 1 over that. The focal length is minus 1 meter, right? So what is the focal length of the mirror? The focal length is minus 1 meter. What is the radius of curvature? To get the radius of curvature, all you need to know is that the focal length is the radius over 2. And since the focal length is minus 1 meter, in this instance the radius of curvature is minus 2 meters. What does the negative mean in terms of this? The negative means that it is a convex mirror and creates virtual images. And that's it for problem 10 and all of homework 7.